the heave period of a vessel. So let's say we have a vessel with a mass of 167,895 ton. It has a water plane area of 12,600 square meters. We have a density of 1.025 and a gravity of 9.81. Then we also would like to know the beam of the vessel, which is a 43 meters and a draft of 13 meters. So we're interested in the heave period, which is the square root of virtual mass, water plane area, rho, and g. Okay, well, let's start with the virtual mass, which is the actual mass added by the added mass, which is the mass plus the mass times the beam to draft ratio. Oh, we could write it easily as the mass is 1 plus the beam to draft ratio. Okay, well, let's find out what the beam to draft ratio is. Well, that would be something like 43 divided by 26 will be 1.65. So the virtual mass is actually 2.65 times the normal mass, which is given over here, which will be something like 44567.5. Okay, tons. Yeah, we could skip the decimal 5, but that's okay. Water area is known. Okay, so we can fill that in. After some calculations, you could find out that this would be something like an 11.8 seconds. Okay, say we have a wave height of 3.0 meters. I would be interested in the acceleration. Well, the acceleration is the movement in the z direction and then the second derivative, which is known, see the previous screencast, as amplitude times omega squared times the sinus omega t. But if we were interested in the maximum, we could just say, well, the maximum value of this one is a 1. So this would be a omega squared. So we're only interested in the maximum acceleration. We know the amplitude, which would be a3, but the omega, well, we found out here our heave period. So if the heave period is 11.8, we could say that the omega is something like 2 pi divided by t, would be something like 0.53 something. Okay, so if we square that one over here, you can do that one in your calculator, I get something like an acceleration of 0.85 meters second squared. Okay, so this is the acceleration due to the heave movement in waves of 3 meters with this given heave period. Interesting. Thanks for watching.